Before I begin section 2, what I want you to do, hopefully I pass this out to you today, mark this at 0 degrees, and I want you to fill in the following numbers in the degrees column. So I put in 0, now put in 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330 degrees. And we will deal with that, bring that tomorrow. All right, arc length and sector area. Before we get going on this, let's take a little review. If this is x degrees, what is the measure of this arc? You got to remember that from geometry. That's also going to be x degrees. Since we've already dealt with radians, if this was x radians, then the measure of this arc would also be in radians. And that goes back to a geometry theorem. And write this down. So we have the measure of a central angle equals the measure of its intercepted arc. Write that down, the measure of its intercepted arc. All right, let's take a look at a problem here. We have circle A. Oh, by the way, if I write this symbol there with a letter after it, this means circle, and this is the center of the circle. And that's what's going on here. So when I write it over here, it's circle with the center A. Find the measure of arc AB. Well, that would be right here. What is that answer? The measure of arc AB is pi over 3. Because the measure of the arc equals the measure of its central angle. Now, is that the same thing as arc length? Well, what if I drew a couple circles with the same center here? Oh, I just realized there's a typo there. This can't be A because A is on the circle. So let's write this as circle O, and I'll put in O there. What can you say about the measure of all of these angles? Now this figure is not drawn to scale. All of these are pi over 3. Does that mean their lengths are all pi over 3? No. Remember, what is pi? Pi is just a number. It's saying the measure of this, not the length. So is that the same? No. How would you find it? Well, I was trying to emphasize when we were dealing with the converting degrees to radians and vice versa, a proportion idea. How can we think of a proportion in a problem like this? Well, we're trying to find a length. Let's think part to whole. What is the whole length? And in this case, what would you call that? That is the circumference of the circle. The whole length will be 2 pi times 8. Now, what ratio are we going to have that we also know? What else do we know? We know pi over 3. Well, that's going to be the part that we're dealing with. It's pi over 3. What's the whole part? Well, that would be the measure of the entire circle in radians. And that would be 2 pi. So this is we're going to solve this. We'll multiply both sides by 16 pi. This is going to reduce to 1 over 6. Now, if you're not really sure, I can write that out. That's pi over 3 times 1 over 2 pi. And then the pi's will reduce, so we're left with 1 over 6. And we're going to multiply that by 16 pi. And 16 can reduce with the 2, and we'll get an 8. So we have 8 pi over 3. Now, what are the units of this? Well, we weren't given units. They're just going to be called units. Since there's a pi in it, does that mean it's a radian? Definitely not. Remember, pi is just a number, 3.14159, approximately. So now we have circle A. How is this problem different than the one we just did? Well, now this central angle is given to us in degrees. But our setup is going to be very similar. We have 2 pi. In fact, let me just write 16 pi. We've already done it once. Oh, sorry. I just realized that it is a different radius there, so this time we'll have 18 pi. What is our part? It's 100 degrees. What is the whole? 360 degrees. What's going to happen to the units degrees? They reduce out. So we can start reducing this. We have divided by 10, and this will end up giving us 5 over 18. So we have L equals 5 over 18 times 18 pi, and we get 5 pi. Again, 5 pi what? It's just 5 pi. We don't know what those units are. So we'll say 5 pi units. All right, in general, if we have some circle, and we'll call that circle O, and we have a radius and an angle theta. I couldn't see that for a second. Now let's assume for a second that theta is in degrees. Then what would we do? It is L to the whole circle, 2 pi r, as theta is, what are we comparing this to? The whole circle. If we're in degrees, it'd be 360 degrees. So we have theta divided by 360 times 2 pi r. And you can simplify that to pi over, or theta over 180 times pi times r. Well, this would be degrees, degrees, and eventually the degrees will reduce out once you plug that in. Now let's assume that it is in radians. So theta is in radians. So how does this change? We have 2 pi r. L is to 2 pi r. It's the same thing. We want part to whole. Theta is, what's the whole circle? 2 pi multiplied by r, 2 pi r, and we get theta times r, or r theta. Now let's take a look. We have one way to set it up here, and that we're looking at the proportion, two ratios that are equal. How can we think about this second one? What this is doing is theta over 360 is saying what part of the circle do we have? We're taking that fraction of the circle and multiplying it by the circumference, and that will give us the part length that we want. And the same thing when we say theta over 2 pi. Now, as a general statement, I don't want to deal with memorizing this stuff. You should be able to derive it fairly easily. If we're dealing with it a lot, it's okay to use that. All right, let's see the next problem. Now, we have find the area. How is this going to be of the same circle? Well, we want a sector. First of all, we need to know what is a sector. A sector would be like this piece of pie. Okay? So, what is the area of that sector? We're going to set up very similar. We're going to say the area, again, part to whole. What is the whole circle in terms of area? That would be pi r squared. And now we have 100 degrees over 360 degrees. And I might as well just change that r to pi times 9 squared. We can reduce, we've already reduced that before, down to 5/18, and we're going to multiply both sides by 81 pi. And so we need to reduce this. We can go, 9 can go into that one 2 times, and 9 goes in 9 times. So we have 45 pi over 2, and then we can say square units, or unit squared. Now, typically I'll get a question, can I write that in a decimal? Yes, you can write 22.5. Since that's an exact number, I have no problem with that. I'd prefer you to have the exact number, so there's no need to multiply this out, multiply the pi. If you had, let's say this was 45 over 3, then I don't want to see a rounded number multiplied to pi at all. If you have a rounded number, you just go ahead and multiply the whole thing out. Let's take a look at the next one. How is this one? Now, notice this one, that I have some inches here. So I'm going to have to make sure I include that in my final answer. We're going to say area is to the whole area, pi r squared, 100 pi, as 5 pi over 6 is to 2 pi. The pi's will reduce out, and we're left with 5 over 12. And we're going to multiply that by 100 pi. So what will go into both of those? 4 will go into both of those 25 times and 3 times, so we're left with 125 pi over 3 units squared. And this is an example of what I was talking about before. 125 over 3 does not go, it's not an integer, so don't try to convert that into a decimal. It's best just to leave the fraction. Now let's look in general. In general, we'll take that same setup and we'll have a circle O. My figure is not to scale, and that's okay. And we'll talk about degrees for the beginning part. A is to pi r squared as theta is to 360. What I want you to see here is the similarity between all of this stuff. Times pi r squared. And there's nothing to simplify for that. But we could also think, what fraction of the area am I looking for? Theta is in radians. So we'll have area is to pi r squared as theta is to 2 pi this time. So the theta is to 2 pi. What fraction of pi r squared do I want? And you can say that this is the same as 1/2 r squared theta. All right, here's a challenging problem. A sector of a circle has perimeter 12 and an area of 8. Find all possible radii. So let's draw it first. Now, what does perimeter mean? It means all the outside pieces added up. So there's a couple things going on here. We have some radius. I don't know what that is. And we're going to have this length. Now, we could, and we don't know what this angle theta is. I could derive that right now. I could say theta is to 2 pi. Now, it doesn't actually tell us we're in radians, but it's easiest to be in radians. Theta is to 2 pi as that arc length is to 2 pi r. So we multiply both sides by 2 pi r and we get r theta. So this length there is r theta, which says our perimeter of this sector, actually of any sector here like this, would be 2r plus r theta. And we know our perimeter is 12. So we have some equation. Now what do we notice on here is we have two variables. We have r and theta. Now let's take a look. We have another piece. We have area. Well, what is area? Well, I could rederive it right here, or I could just look. We just did it. So we could say 8 is equal to 1/2 r squared theta. Now note we have two equations with two unknowns. How can we solve that? Well, we have a system of equations. We've done add subtract with linear equations, and we've done substitution. What do you think would be best? Substitution. Now, which of the variables do you think we should solve for? This, we could solve for r if we factor it out, but that's not so easy. Over here, I definitely don't want to take the square root and start dealing with plus and minus stuff. Let's solve for theta here. If I solve for theta, I'm going to multiply both sides by 2, and I'm going to divide by r squared, and that will give me 16 over r squared. I can take that and plug it in for the theta over here. 2r plus r times 16 over r squared. So we get 12 equals 2r plus 16 over r. Now we have to remember what we did way back in chapter 1, and we also did it in chapter 5. How do you solve this equation? We have an r in the denominator. We don't like that. How do we deal with that? We're going to have to multiply everything by r to get rid of that fraction. When we multiply by r, we'll get 12r equals 2r squared plus 16r. And let's come over here. Give me some room. And I'll move everything to one side because what do you notice? We have a quadratic formula, or a quadratic equation, excuse me. And we can solve it using the quadratic formula, or we could solve it factoring. What do you want to do? At first, I want to try to take out that 2. And we could either divide everything by the 2, which I think would probably be easier in this problem. So if we divide everything by the 2, we'll have r squared minus 6r plus 8. Do you want to use a quadratic formula or factor? Hopefully you say factor right away. R minus 2 times r minus 4, so r equals 2 or 4. Now, if r is 2, that means theta would be 16 over 4, or 4. And if r was 4, then theta would equal 16 over 16, which is 1. What does that look like on a circle? Remember, what is 1 radian? 1 radian is the radius mapped out onto it. So if this had a radius of 4 and we had this angle here, theta of 1, then this whole perimeter would be 12. If we had a smaller circle, but we had all the way to 4, remember going straight across was pi, so 4 would be something like this, and I take this, and then the radii would be 1, then that sector would also be 12, and again, and their areas would be 8. All right, let's look at the last one. At its closest, Mars is about that far from Earth, and its apparent size is about 0.007 degrees. Now, let's take a look at this idea. What's the approximate diameter of Mars? We're dealing with Earth, and way over here we have Mars, okay? And I know my relative size is not right. Well, if I think of this as being a circle, and I could draw that around, and I look at where the circle cuts through Mars, now compare that to the diameter. Well, since this distance away is so big, that arc of the circle is approximately equal to the diameter. And that's the idea we're going to use here. What we want to do is basically deal with an arc here. If I know this is 0.07 degrees, and I'm going to say find this length, let's call it x. And I know my radius is 5.6 times 10 to the 7th. So how do I do it? Well, I can say x, my arc length, is to 2 pi times 5.6 times 10 to the 7th. Let's make that look right. Equals 0.007 divided by 360 degrees. So we get x equals whatever that is, and I'll write it here, times 2 pi times 5.6 times 10 to the 7th. And at this point, you just get out your calculator and type it all in at one time. So I have 0.007 divided by 360 times 2 times pi times 5.6 times 10 to the 7th. And I hit enter, and that gives me approximately equal to 6841.7. Now, when we look at this, 5.6 times 10 to the 7th, that's a very rounded number. I'm not going to get into sig figs on this type of problem. If you said here, unless I told you otherwise, and just said, it's about 6,842 what are the units of this thing? Kilometers. That would be okay. I'll tell you in general what to do for the rounding of a problem. And that's it for section 2.